All right, hello once again, Jeff Scott of Rankin Technical College. As part of the Rankin Technical College Application and Website Development, or AWD1100, Programming Fundamentals with C# course, I've been doing a series of video presentations that are based on the PowerPoint slides for our textbook, that being what you can see on the screen right now, Muroc C# 7th edition. I have finished about half, so I've done all of Section 1, an Introduction to Visual Studio, just finished. Section 2, the C# Language Essentials, which brings us to Section 3. Now, this is a totally different, what they call a paradigm or a way of looking at things. So we're going to talk object-oriented programming. Many people find this to be probably the hardest part of the book. But we're going to try to take it slow. We're going to concentrate in this section. We're going to concentrate on chapters 12, 14, and 16, and have very little to say and do with 13 and 15. Now, chapter 12 is on how to create and use classes. All right, and we're going to jump into that right away. Whoops. So here's our cover slide, and as you can see, how to create and use classes. All right, I'm not going to read these to you, but the applied is basically how to bring classes into a C# program. And the knowledge is some of the terminology about object-oriented programming. We're going to discuss what the 3 layers are, what a constructor is, what a method and field is, what encapsulation, instantiation are, etc. Please don't let it throw you if you are watching this video before we've gone over it in class and it doesn't make total sense to you. All right, so the first thing we talk about here is this 3-layered application. Now, this is not exactly what I'm telling you right now. This is not exactly it, but in other classes we refer to basically this kind of structure as being MVC, or Model View Controller. All right, and the model is basically, typically it's your data. So it's what you're trying to model. It's what they show here as the middle layer. All right. In fact, you could really say it's more the database layer, I guess, in here. All right, because it's your data. The view is what the user sees. All right, it's what the end user sees. And the business classes are kind of the link between those, because the presentation layer and the database layer typically do not directly, really should not directly communicate the first layer and the third layer here with one another. Rather, they should communicate through the middle layer. Now, if you say, well, that didn't totally make sense, it's to be expected. Now, throughout this section, and actually into the last section of the book too, talking about databases, they're going to be working with this product class. So we're going to look at this in a lot of detail. All right. So notice that when you start to talk about a class is made up of properties and methods. Now, again, many people find this confusing. So let's assume for a second that rather than a product class, like they talk about, we have a person class. All right. And we want to find out their properties, and we want to find out, let's just do it like this. I'll move this over a bit. And we want to find out about their methods. Okay. All right. So their properties are basically things that everybody has. So in other words, every person has what? A height, a weight, an eye color, other than, I guess, if you're bald, a hair color, and a gender. All right. So really everybody has those. Again, don't worry about it. You say, well, what about it? It's not that big a thing. And every person can eat. Every person can drink. Every person can, sleep. Every person can talk. We'll leave it at that. But what I'm trying to show you, our properties are the things that make us unique. Methods are behaviors that we all share. We all eat, we all drink, we all sleep. Now, I know there are people who don't talk, but we could have changed this if we wanted to communicate. Because even those people who don't talk, typically at least, imagine, I would imagine, manage to communicate with one another. So these are going to be the things that kind of make us unique. There are properties. These are going to be the behaviors that we have. All right? So when we apply that towards this product class, look at their properties. Every product has a code. As it says, it's a string that's some kind of a unique identifier. Every product has a description, another string that has the description of the product. Every product has a price, which is that product's price. And every product with this get display text, that means that we can display every product. The key one in here, really, when you think about it, is the code, because that's what differentiates each product from one another. Now, when you create a brand new product, so when we create a new member, what's called a product object, and a product object is a member of the product class. Just like a Jeff Scott is a product, or not a product, is a part or a member of the person class. All right? So the methods here, we've got to get display text, and also when you create a new product, when you create any object of any class, you do it using a constructor. Now there's two different constructors here. And what that means is we can either create a brand new product and pass nothing to it, or we can create a brand new product, and notice these three properties, we can pass all three of them in. Now, if we do this and pass in nothing, I'm going to move way up here and I'm going to come back again. I know it's here because I saw it. There we go. So if we pass in nothing, our strings are going to hold the empty string, or null. They won't hold a value, and our numbers will hold 0. So in other words, if I create a brand new product and I pass in nothing, the code, which is a string, will be null, or the empty string. The description will be null, or the empty string, and the price will be 0 if we create a new product like that and don't pass in any parameters. If we don't do it like this, we must do it like this. So when we create a new product, we must either pass in 0 parameters or 3 parameters. That's the only way we can do it. Now, here's some terminology. So they define a property as a data value associated with an object instance. A method is an operation, or what I call the behavior. A constructor is a special type of method that gets called when the object is created or instanced or instantiated. Now, the next two we're not going to talk about real much, because that's where you can really kind of fall off the deep end here and get very confused talking about object-oriented programming, and those are delegates and events. A delegate, as it says, is a special type of object used to pass a method as an argument to other methods. Don't worry about that for right now. An event, really, an event's not that different from the events we've been talking about. All right, and what I mean right there is, so far in our programs, basically the only thing we've been responding to have been click events of buttons. All right, a field, a variable that's declared at the class level. So a field basically is a property. All right, and a constant is just that. It's something whose value cannot change. Again, we're not going to worry much about indexers, but as it says, it's a special type of property that allows individual items in a class to be accessed by index values. An operator is a special method, all right, and a class, as it says, a class that's defined within the class. Don't worry about all that stuff. Some more terminology for you. All right. First, we've got an object, kind of what I talked about before. If you look at a class as being a blueprint, most people, so let's pretend for a moment that I am going to go and build a new house. All right. And I've got the lot. All right. And, typically before I dig any ground, have them dig the basement or do whatever, what's going to happen first is I'm going to have some kind of a blueprint or architectural plan of what the house will look like. And I'll okay that first. That architectural plan is the class. All right. My house would be an example of a house object. So it would be an instance of that house class. So as it says, an object is a self-contained unit with properties, methods, and possibly other things. A class contains the code that defines what the individual objects will look like. So an object is an instance of a class. When you create an object from a class, it's called instancing the class or instantiation. Encapsulation, well, this is the example I always give for encapsulation. Maybe it's good and maybe it's not. But if I bring up the calculator and I come in here and I type in 365 and I click this, what is that? I believe that's the square root of 365. All right. Now, how did the computer take this and convert it into this? And the answer is, I have no idea. What I see right here, when this comes up, and I put in this, and then I put in this, and then I put in this, etc. When I do that, all right, that's what I see here on the screen with these buttons and with this label or whatever this is. All right. This is the implementation. I'm sorry, this is the interface. This is what I see, my interface. Now, what happens when I put in this and then click this, what happens behind the scenes, that's the implementation. All right. Why am I telling you that? Because what encapsulation allows you to do is it allows you to break up what you're doing into an implementation, which is what happens underneath the hood, and an interface, which is what you show the user. So imagine that the day comes, and I mean, when I type in 365 and I hit this, I get it instantaneously. But let's pretend for a minute somebody comes up with an even better way of creating a square root. So when I do this, and I do this, I get it even faster. If my interface does not change, if it still looks just like this, and somebody changes what happens behind the scene, as the saying goes, I'm never the wiser. It's totally fine. So what happens when you've got an interface and an implementation is as long as the interface does not change, the implementation or what happens underneath the hood can change because that information is encapsulated or hidden from you. So as it says, the data is typically encapsulated using data hiding. And again, that's basically the way that I look at this, is the process of breaking this up into the implementation, which was what happens underneath the hood, and the interface, which is what you show the user. All right, most of the classes you create will have just properties, methods, and constructors. So here's our first example of looking at a class. The first thing to tell you, probably the most important thing I've told you so far in this chapter, class files contain only code. In other words, class files do not have a GUI associated with them. We can link them to a file with a GUI. We do not even have to do that. All right. So as we saw earlier, the product class has three members: a string with the product code, which means it can contain letters and numbers, special characters, etc., a string for the product description, and a decimal for the product price. Now you'll notice if you look at these, the class is public. What that means is that class can be called, that class can be used by other classes. All right? But the members of that class, these things right here, these members are private, which means they can only be manipulated by the public methods inside of the class. So I had a student once ask me to kind of give them a one-sentence explanation of what object-oriented programming, which is what we're talking about now. They wanted basically it boiled down into a one-sentence explanation of what object-oriented programming is. And the answer that I gave them, it wasn't perfect, but I said, by and large, what object-oriented programming is, it is using public class methods. It's using public class methods to manipulate private class variables. Now, that's a generalization. I said public class methods. Can you have private class methods? The answer is yes. Typically, when you have private class methods, they are referred to as either utility methods or as helper methods. They're methods that are used by these public methods to do things behind the scenes that have to be done. Now, I've given examples of this before. I'll just give you one right now. Let's suppose I have two students in my class right now. I've got Bill and I've got Mary. And Bill, let's just suppose that this is all contrived. I'm making all this up. Let's say that Bill owes me a favor. So I say to Bill, hey, Bill, I'm really busy right now. Would you do me a favor and go downstairs and get me a soda? Bill says, yeah, that's fine. I'll go down and get you soda. So I give Bill the money for the soda, and he goes off. Right as he's about to go downstairs to get the soda, he sees Mary. Mary owes Bill a favor. So Bill says to Mary, hey, Mary, go downstairs and get me a soda. Please, here's the money. So Mary goes downstairs, gets the soda, gives it to Bill, who gives the soda to me. Now, I'm not the wiser. I don't know, nor do I care, that Bill had Mary do the work for him. She was kind of Bill's helper function, so to speak. So the namespace we've had all year, we've been using public classes, but really the class so far that we've been using has been something that's been a form or whatever. This is a separate standalone file that's going to be called product.cs. It's going to hold a public class. Classes can be one of 3 or 4 different things. They can be public, they can be private, they can be protected. So what's the difference between them? Most classes, or at least many, are public, which means they can be used by or communicate with other classes. If a class is private, then typically who else the class can communicate with is very limited. And if it's protected, the class can only communicate with, for lack of better words, siblings, children, grandchildren, great-grandchildren, etc. So a class doesn't have to have any class members. It doesn't have to have any properties, but typically it does. So these are the 3 properties of the class: a string for the code, a string for the description, and a decimal for the price. Again, you'll notice they're private, which means the only way that we are going to be able to manipulate these 3 properties will be by using the public classes. There they are. So let's go and look at all of these. These 2 things that you see right here, these are the 2 constructors. the way they're showing this right now, where typically after you declared the class name, you put in the properties, then you put in the constructors, then you put in all the class methods. That's usually how you set up a class. That's the way most people do it. That's the way most people expect it to be done. So this is our constructor, what I call our no arg constructor. There are no arguments. So it's going to set code equal to the empty string, description equal to the empty string, and price equal to 0. This is what I call a full arg constructor because all 3 arguments are passed to it. So whatever I pass in here for code, I'm going to set this. Whatever I pass in here for description, I'm going to set this. And whatever I set for price, I'm going to set this. Now you look at this, no pun intended, and it's a little confusing. What does the word this? It's syntactical in nature, and you say this dot, and you use the same name that you had here, except you uppercase. This should be lowercase. This is uppercased for the first letter. So this says I want to take my product and I want to pass in a code, a description, and a price, and I want to set all of these, and I set them in here. Now that may or may not make a lot of sense, and hopefully it'll make more sense as we go on. Well, what if I do this? What if I call this one right here? Now my product has no code, my product has no description, my product has no price. Or what if the description changes, or more likely, what if the price changes? So what I have here and here and here in the next 3 things is these are methods that I can use. They're called getters and setters. So if I want to be able to either access, if I want to be able to access the code, I use a get. If I want to be able to give the code a new value, I use a set. And you'll notice again, we use the capital letter there, even though this is referring to that right here. And again, this is something syntactically done in this language. Not all languages do it like this. So we've got our getters and setters, all right, for our code. We've got a getter and setter for the description, and we've got a getter and a setter for the price. What oftentimes also confuses people is what the heck did value come from? Value is whatever whenever you want to change the code or the description or the price, it's automatically put into a special system variable that's called value. All right. This is the other method. This method right here on slide 14 is what we talked about back here on slide 5, this get display text. So this is going to allow us to display the code, followed by some kind of a separator, followed by the price, followed by a separator, followed by the description. So I'd have the code. The separator could be a tab, for example. So I'd have the code in a tab, the price, then a tab, the description. All right. Or the separator could be just a blank space. So I'd have the code in a blank followed by a blank space, the price followed by a blank space, and the description. Or the separator could be a comma. So I'd have the code, comma, price, comma, description. The separator can be anything we pass in. All right. So here's some examples. Okay. So these are 2 examples of products that have been created. These are supposed to represent Muroc books. The first product has a code of C#. It has a description of Muroc's C#, and it has a price of $59.50. The second product has a code of ASP MVC, a description of Muroc's ASP.NET MVC, and a price of $61.50. Here, this line right here, we are declaring 2 products. We're just declaring them right there. We're not instantiating them. We're declaring that they exist. These 2 lines and really it's over 2 lines, but I get it. But these things, the product 1 and the product 2, those are instantiating 2 different products. One named product 1, one named product 2, and it has the price, the code, the description, and the price that we mentioned up here. Okay? All right. If we do this, if we create an empty product, then we come in and set the code and set the description and set the price. That means that we called this particular constructor because we passed in nothing. And then when we manually set code, we did it here. We call that setter. When we manually set the description, we did it here. We call that setter. When we manually did the price, we did the setter right here. That's what they're talking about. All right? And you'll see we can declare an object and then instantiate it like this, or declare it and instantiate it like this, or used what's called an object initializer. So again, there are multiple different ways that we can do this. All right? Okay. So as it says here, here's 3 different ways that we can declare and create an object. What's the difference between them? The standard way, the way that it's done in most other programming languages other than C#, is the first way, where you explicitly type an object. So in other words, object type, object name equals new object type. That's explicitly, meaning we as programmers are explicitly giving it that name and type. Here we are implicitly doing it. So by using the word var, we're letting the system figure out, oh, it's a new product. You can also just do this and just say new like this. And as it says, C# 9.0, so that's a fairly new invention, so to speak. To create a brand new class, and let me show you this. Where am I here for time? I'm totally fine. All right, so if I come in here, and I have not done any work right now with this, so let me just grab, I don't know if this is even the one. Let's see, measurement cannot be, of course not. No. Let's open a project or a solution. So I'm going to go to my desktop. I'm going to find where I've been putting all these programs that I've been working on. If I can find it. It is not it. Okay. Did I put it in here? Yes, I did. So AWD1100 in-class programs. So I'm going to grab one that we used a while ago. All right, so let's see. Here's a simple calculator. I don't even remember doing this, but let's look at that. So let's look at this. Okay, operand, operator, operand, result. Okay, it's pretty obvious. So I come in here and I do all this. When I hit the calculate button, it should give me 32, right? Okay. If I instead change this to a times, it's 55 times 23. I don't know what that is. It must be about 1200, 1215, 1265. If I divide, boom. I don't know if I put a modulo in here. Got one. And we've got plus. So you can see all that stuff worked. What if I decided I wanted to take the functionality to add, multiply, divide, and subtract and put it in its own part of the code? I could come in here, right mouse click on the name of my project, and choose add, and then either go down near the bottom and choose class, or go to new item and choose class. All right, I'd have to look for it in here, but I know there's a class in here someplace. There it is, right on top. So if I do that, and let's just say, I'm going to remove this right away, but I wanted to make a new class called math. Math.cs. So I hit enter, and notice it gives me a brand new class. It's called math. Now usually I'm going to change this from internal to public, and now I can put whatever I want to put inside of here. And if I bring it in, I will be able to use that class inside of this particular program. This is the kind of thing that we're going to be looking at in just a bit. All right. And again, I'm not saying, does that totally make sense? Okay, now ours said internal, all right, rather than class project, but typically you would change that to public class product for this example. So here they have come in and created the fields. Now they're going to go in here and talk about public fields and read-only and public and private fields. Most of the fields you create in a class will be private. There is almost never going to be a reason to make fields public. It's not that you can't do it, but you don't typically want to do it. You want to limit the scope and limit who can change the value of the variable. So here's a public class where they put in all public fields. And if you say to yourself, well, you told us you shouldn't do that, why are they doing that? I don't know. Because they are. So these properties can be public, okay, but usually they're private, and what you do is you make your getters and setters public. Now, when we looked at those getters and setters before, all we did was return something or set something. We didn't do anything else. And when you look in here, now they're doing stuff. Where are we? There. We're setting something here and then returning it. All right. And you can do that. You can put, this doesn't have to be just one line of code. Oftentimes it will be, but it doesn't necessarily have to be. Not only that, and not to confuse you even more, but notice this says read only. If something does not have a setter, it is read only. If something does not have a getter, it's write only. You'll almost never see a write only property, but it's legal and legitimate to do that. All right, there's a setter, which means that the name of the property appears on the left-hand side of an equal sign. There's a getter, which means that the name of the property appears on the right-hand side of an equal sign. All right, okay. So again, most methods are going to be public. Here's an example of a method that requires an argument. Here's the same method that doesn't require an argument. So notice the names of these two methods are the same. Public string get display text, public string get display text. But what's referred to as the method signature, which is what goes in the parentheses, is different. So you can have two methods that have the same name, just like we did before when our constructor had the same name, and one time it was empty and one time it had the code and the description and the price. When you have two methods with the same name but different signatures, those are known as overloaded methods. Okay? All right. So here we're calling get display text, and we're saying that the separator it should be a tab. Here, notice we've got a comma and a space, so that's going to be the default if we pass in nothing for a separator. So this right here will say product code tab, product description tab, product price. This one will say product name, comma space, product code, comma space, product description, comma space, product price. It is an overloaded method. All right. So again, this is more of the same. Here's our constructor with no parameters. Here's our constructor with 3 parameters. So this is an overloaded constructor. What's different between the two? Don't even worry about what's in the curly braces, because what's different between these two constructor methods, and remember, a constructor is a special method that's called when the class is created. All right, so the difference between these is that method signature. Here, there's nothing inside, so it's a no arg or no argument constructor. Here we've got all 3 of our arguments, so it's a full arg or full argument constructor. All right. Can you have a constructor which is some parameters? Yes. They didn't set it up like that here, but you could have, sure. This you've seen already, and as it says there, these are the default values. So when you have instance variables, if you've got a number and you don't pass that number in, it defaults to 0. If you've got a Boolean property and you don't set it, it defaults to false. Char and objects default to null, and date defaults to midnight, January 1st of the year 1. All right. So they're going to talk about static members in here. All right. And static, typically, for lack of better words, static typically means shared. All right. Static typically means shared. All right. And here's something that we're going to hit on this in much more depth and breadth of coverage when we are going over this in class. I guess for lack of better words, for now, you'll have to take my word for it. Now, this is what we're going to be working on for much of the rest of the semester. Okay? So every time we want to add a new product, we're going to be using this form right here. And when we add a new product, we're going to be instantiating or creating a new product. That product then must have a code, a description, and a price. So when we fill in these fields and we click Save, it'll add it to our list of products. So right now, you don't see this product in here. But if we put all this in and click Save, now we'd see here ASP MVC right there. We'd see right here 6150. And right here, we'd see Murox ASP.NET MVC. All right. Now, this tag property that I've talked a little bit about before, all right, is going to be important because it's what it says here is this text box is going to have a tag of code. All right. This text box will have a tag of description. This text box will have a tag of price. The tag is an important property. All right, when I say property, it's something in our properties window. And I mentioned this to you before, but if I jump back into here and I click right here, notice I have not set the tag. Here, it's not set here, or here, or here, or for any of my buttons. But as we go on and build more and more complex applications, there's at least a chance you're going to be grabbing all in here, some, most, or all of your controls and setting the tag property. Okay. So our product class has these 3 properties. It has this special method, and it has 2 constructors. Now, the product DB, and what that means is DB is short for database. So we're going to be storing these in a database. Now, we won't get to the database part until like chapter 19 or 20, and we're only in chapter 12 right now. But they're setting up a special class called DB right now that's going to be able to hold all of our products. And you'll notice we've got get products, which is going to return a list of all our products, and save products. So when we call get products, it shows us this. It shows us the list of existing products. When we call save products, that's what's going to happen. We click that save button, and it'll have to add the product that we just filled up into our list of products. I can't say it any more cleanly than that, and hopefully at least it makes at least a little bit of sense to you. All right. So we've got this validator class. This is where this stuff is really going to be important. All right. And we've got this line end, which tells us basically when we've reached the end of a line. So when we are printing this out, when do we stop? We stop and we put a \n, which means rather than printing all these on the same line, we print on a line, hit do a \n, we print on the next line, do a \n, print on the next line, do a \n, and print on the next line in that case. These things right here are going to be coming in, and they're going to be checking the values of our different properties that we're setting. Is that value present? If it's an integer property, is it an integer? If it's a decimal, is it a decimal? If it's a price, for example, is it within range? We're going to be hitting on all this stuff in here. The is present, is int. We're going to be using all of these in class. All right. Let's see where we are. Okay, we're at 42 minutes, so I'm going to stop right now. I'm going to pick this up. I'm about halfway through the slides. I'm going to pick this up then in the next chapter, so I'll be back with that shortly.